Most AI models today generate text one token at a time, slowly predicting each next word based on the one before it. It's how tools like ChatGPT or coding assistants typically work. While it sounds smart, it actually creates a serious speed limit. This step-by-step process drags down performance in everything from writing code to handling real-time tasks. But now there's a new model called MERCURY that completely breaks that rule. Instead of guessing one token at a time, it generates many at once using a method called diffusion. This is something that has never been done at this scale for language, and the results are shocking. MERCURY is not just faster, it's on a completely different level. Inception Labs looked at the bottleneck and said, why not jump tracks entirely? Instead of guessing tokens one after another, their new model family, called MERCURY, uses diffusion. The same broad idea that has made image generators so good. With diffusion, you start from random noise and tidy it up step by step. But here, those steps happen across every position in the sentence at once. Because modern GPUs can crunch loads of matrix math in one go, MERCURY ends up generating code far faster than the older approach. The smallest public version, MERCURY Coder Mini, has been timed at 1.19 tokens per second on an NVIDIA H100 card. The slightly larger MERCURY Coder Small still churns out 737 tokens per second while adding a bit more brain power. Those speed readings come from Artificial Analysis, an independent firm that times models under the same rules, so it's not just marketing fluff. Speed isn't the whole story, of course. A coding assistant that misplaces a bracket isn't helpful. So the MERCURY team also measured quality on the usual scoreboards. Human Evil, which asks the model to pass hidden Python tests, shows that MERCURY's Coder Small reaches 90%, and Coder Mini lands at 88%. Another Python test set shows 76% for the small version and 77% for the mini. Evil Plus, which repeats those tasks with stricter hidden checks, keeps the small version at 80%. Then there's Multiple, which spreads questions across C++, Java, JavaScript, PHP, Bash, and TypeScript. The small model averages 76.2%, while the mini averages 74.1%. In short, the larger small model sits comfortably with frontier speed-tuned offerings like Claude 3.5, Haiku, and Gemini 2.0, outperforming them 3 to 10 times faster. The smaller mini model sacrifices only a few accuracy points but still outruns almost everything else. The magic happens because diffusion allows the model to polish the whole answer together. Traditional models build answers from left to right, one word at a time, like typing a sentence and never being able to go back and fix anything. Diffusion flips that idea, working more like editing a shared Google Doc, where you can tweak any part of the answer at any time, even go back and rewrite the start after you've written the end. This is especially useful for coding, where something you add at the bottom might change what needs to happen at the top. Because each pass updates the entire answer at once, it runs much faster on modern graphics cards, which are built to handle tons of calculations at once. During training, Inception Labs took trillions of tokens, no exaggeration, using a blend of web crawls, synthetic examples, and proprietary repositories. They added controlled noise and taught the transformer to denoise it step by step, treating easy and hard steps differently. The model first sketches broad structure, then perfects details like indentation and naming. Since the backbone is still a normal transformer, all the genie bottle tricks developed for standard language models, like flash attention, kernels, half-precision math, and key-value caching, fit right in. The heavy lifting went into redesigning the sampling loop, not the neural network layers themselves. Serving a diffusion model well is its own art. Here, Inception Labs built a custom inference engine. The engine decides on the fly how many denoising passes a prompt needs and batches multiple users so the GPU never sits idle. Simple prompts might finish in 8 quick passes, coming back in just 25 milliseconds. Larger prompts can run the full schedule, still processing hundreds of tokens per second from a developer's seat. Nothing exotic changes, The public API speaks the familiar OpenAI JSON dialect. This means swapping is as simple as changing one base URL in your client code. Context window length matters when you paste entire files into a prompt. Mercury ships with 32,768 tokens of context out of the box and can stretch to 128,000 with an extension trick. That's long enough to drop in a whole Kubernetes manifest with notes and still have room for instructions. Alignment and instruction tuning follow the same recipes you've heard. Reinforcement learning from human feedback, direct preference optimization. But the loss function becomes a diffusion denoising loss instead of the standard next token loss. Early testers report that chain of thought prompting, few-shot, and zero-shot tasks still work, which makes sense because the conditioning interface remains unchanged. To see how humans react, look at Copilot Arena, a blind taste test site. Developers there choose between code snippets without knowing which model wrote them. Mercury Coder Mini tied for second in overall ELO score, but delivered the lowest average latency, just a quarter of a second. GPT-4, Mini, Codex Terra, and Gemini Flash needed several times longer to draw their first characters. Reviewers noticed Mercury's answers felt concise, with no surplus verbosity, perhaps because global passes discourage token fluff. It's worth comparing Mercury against the usual top performers. GPT-4 Mini reaches similar accuracy, but tops out at just 59 tokens per second. Claude 3.5, Haiku, and even Gemini 2.0 Flashlight, with its high-speed mode, barely touches 200. Meanwhile, Mercury, prettily pushing over 1,100 tokens per second, still outperforms them on the speed-to-quality curve, as shown by artificial analysis. Even the heavyweights like GPT-4 Full and DeepSeek version 3 struggle to break past 100 consistently, making Mercury's numbers feel almost unreal in comparison. A fair question arises. Isn't diffusion famous for needing dozens, even hundreds, of iterations when generating images? That's true in pixel space, but text diffusion can cut steps sharply because the denoiser proposes big edits early. In practice, Mercury often takes between 10 and 30 passes. Added together, these passes still spend less time than one autoregressive rollout because every pass covers the entire sequence at once. Another common worry is resource use. The 1.19 tokens per second headline comes from an H100 with hand-tuned kernels. You won't hit that figure on a desktop 3090 using plain PyTorch today. Inception Labs fuses operations in custom CUDA kernels, manages memory to avoid unnecessary transfers, and schedules batches centrally. Whether those improvements trickle down to open source remains to be seen, but history suggests community ports follow soon after commercial debuts once people see the gains. There's a green angle too. If one GPU serves 10 times as many tokens in the same time slot, cloud providers need fewer racks, and smaller organizations can stay on smaller clusters. This lowers the bill and the carbon footprint. As more devices move inference to the edge, think office laptops or on-premise servers, these savings become practical, not just theoretical. The Mercury report even hints that diffusion's efficiency could open room for multimodal expansion, pairing text with diagrams, audio descriptions, or even quick video scrubbing, using one architectural family instead of stitching separate specialist models. The paper also covers scaling laws. Their larger small model beats Mini by a clean margin on every benchmark, implying performance should keep rising as they release medium, large, or beyond. Because each denoising pass is still one forward transformer run, bigger layers could mean both a richer model and even more parallel work per pass. So speed might climb rather than fall up to bandwidth limits. One spot where Mercury still trails is bash scripting, 50% accuracy for coder small versus Gemini Flash's 51%. That shows there's room to train on more shell samples. Yet in JavaScript, TypeScript, and C++, the diffusion model already matches or edges past most rivals. Its fill-in-the-middle scores 93% for single-line gaps in small, topping the charts. Those fill-in-the-middle tasks matter because real coding assistants often work by dropping hints exactly where you're typing, not at the end of the buffer. If you want hands-on proof, Inception Labs runs a free playground at chat.inception.ai. Paste up to 128,000 tokens if you're brave, watch the spinner, and notice how little delay there is before full paragraphs appear. They do throttle heavy users, but it's enough to feel what sub-100 millisecond code completion can look like. Behind the curtain, the training cluster clearly burned serious compute. They didn't publish the exact GPU count, only that everything ran on H100s, and that the data pile reached trillions of tokens. Still, because the same denoiser weights apply across all time steps, fine-tuning floating point operations per sample compared to normal language model fine-tuning opens the door for smaller companies to specialize Mercury on private code bases without astronomical cloud bills. The bigger picture is that diffusion just stepped out of the image world and into the programmer's chair. It isn't tossing out transformers, it's reusing them in a fresh sampling loop that finally breaks that left-to-right handcuff.
If you build developer tools or maintain giant internal code assist systems, the arrival of 700+ tokens per second at solid accuracy changes capacity planning overnight. Alright, that's it for now. If diffusion models are already this fast and accurate, what's stopping big players like OpenAI and Google from switching everything to this approach? Or are they just protecting what they've already built? Let me know what you think in the comments. Don't forget to like, subscribe, and turn on notifications. Thanks for watching.